actually, let's go back. We did not actually look at this. What would this look like in standard form?
X squared plus
X squared plus 3x plus 2x plus 6, right? Equals x squared plus 5x plus 6. So we've already been doing this, correct? We've just been doing the inverse. We've been factoring, this is factoring and then multiplying it out, and this is my standard form. So let's look at this one. This says, write a quadratic equation with 1/2 and -5 as its roots. Write the equation in the form ax squared plus bx plus c. What form is that? Standard form, where a, b, and c are integers. What does that mean, a, b, and c are integers? What do integers look like? Those are numbers on a number line, right? Is this an integer? No. All right, so that being said, so this is saying my roots are 1/2 and -5. What were my roots on the previous example? Not 2 and 3, but -2 and -3. Correct? Because if I were to set this up to 0, wouldn't I get x equals -2?
Yeah.
And x plus 3 equals 0 would be x equals -3. Well, think about that, like working backwards when you look at this. So wouldn't my roots be, I'm going to, x minus something and x minus something equals 0?
Yeah.
So it would be x minus 1/2 and x minus -5. Does that make sense? So, if I gave you this, you all could tell me those are my roots, correct? You just have to think about it in reverse. If I give you the roots, you've got to be able to put it into this form right here. So if you just make sure you start with this skeleton like this, you'll be fine. Start with that skeleton. Go ahead and plug in your roots or substitute in your roots, and you'll be fine. Can you guys all do that tomorrow?
Yeah.
Okay, good. All right, let's take this a little bit further. So now I would FOIL it, correct, or double distribute. So x squared plus 5x minus 1/2 x minus 5 halves. Okay, I said it has to be an integer form, right? So what do I need to get rid of? The fractions. How do we get rid of fractions? Okay, what do we call that? Math. We call it clearing the denominator. So let's clear this denominator and multiply everybody by 2. Wouldn't you say if I had 1/2, can't I multiply the numerator and the denominator by 2? Isn't that equivalent? We're going to use that same thinking or strategy to get rid of these fractions. So can't I multiply everybody by 2 and it would be equivalent? Just as long as I do it to everybody, right? Just like I can multiply, as long as I multiply by the numerator and the denominator, it's legal? Okay. So I get 2x squared plus 10x. My 2's cancel, and I get -x. My 2's cancel here, and I get -5. So the standard form of this equation is 2x squared plus 9x minus 5 in standard form. Okay? So if you get a fraction, all you have to do is multiply by the common denominator and get rid of those fractions. Everybody okay with that? If not, you just FOIL it. The only reason you would have to do anything with fractions is if you have a fraction in here. Okay? Alrighty. More quadratics. Solve 0 is greater than or equal to 3x squared minus 7x minus 1 by graphing. I'm kind of lying, I'm not going to do the whole graphing part. So, let's look at this. Our first, I'm sorry? No, not right now. I'm showing you where we're going. You'll see in a second what I'm doing, okay? Okay, so, first thing I look for is what? GCF. Is there a GCF there? No. Second thing I look for is? Squares. You see squares? No. This isn't one of those nice, easy quadratics where I can just do this, right? So I need to try and use a box method and see if I can factor this guy. So, draw myself a box. 3x squared goes here. Negative 1 goes here. Let's see if we can find factors where I can split up that b. So negative 7x, a times c is negative 3x squared. Is this factorable? It is not. So if it's not factorable, what do I do? We would find the axis of symmetry, right? Then find our vertex, then look for our y-intercept and do all that jazz, right? Or our old friend, a negative boy, couldn't decide whether to go to a radical party or b squared and miss out on 4 amazing chicks that was all over at 2 a.m. You guys heard that one? Okay. Yeah. There's Pop Goes the Weasel. So, no, we're not going to sing it right now. But maybe on Friday I'll play you a few movies that I've got on it or a few clips. Okay, so equals negative b plus or minus the square root of b squared minus 4. I need it quiet, please. All over 2a. So I'm going to substitute those values in there. So a is 3. So I put a 3 here and here. B is negative 7, so that goes here and here. And finally, C is negative 1, so that goes here. When I simplify that, I get positive 7 plus or minus the square root of 49 plus 12 all over 6, which is 7 plus or minus the square root of 61 over 6. And this is where we begin today. We need to be able to simplify this. I just didn't want to throw these out there and go, hey, let's do these. I wanted you to know where I got this from, right? This is where you end up when you're using the quadratic formula. And I want to make sure you guys can do this. So, let's approximate. Yes, you can put it in a calculator, but it is smart to understand how to approximate radicals without a calculator, because you can put it in a calculator and be wrong. All you have to do is hit a keystroke wrong and you're done, right? So we're going to learn to approximate it. So, square root of 61. I may not know the square root of 61, but I know a couple other square roots that are pretty close to it. 64. What's the one below it? Which would be 49. All you got to do is find one and then think of the one that's below it. So if this one's 8, the one below would be 7. 61 is closer to 64. So my answer would be 7 point what? What do you think? I would say 8. That's my point though. Right? Now you get a calculator and you put it in there, and let's see. If I put that in a calculator, I would get 7.8. Now I'm right. And I know I'm right because I did it in my head first, and it makes sense. Rather than just putting in a calculator and going, oh, there's my answer, I hope I'm right. Make sense? You're applying logic, exactly. That's what you should be doing. Just because you can use calculators in this class, you will learn quickly that you should not rely on those calculators solely. Correct? Okay, so now I know I have 7 plus or minus 7 and 8/10 all over 6. So my these are roots, right? If I were to graph it, I would get 7 plus 7.8, which would be 14.8 divided by 6, and negative 0.8 divided by 6. You should be taking these things all the way down to this and making sure that you're getting the right answers by thinking about it first. So our first one is, if I round it to tenths, I get 2.5 and 0.1, negative 0.1. Questions so far? So these are my roots. If this was 1, 2, 3, I would have one root here and one root here. Can anybody tell me from looking at this how the rest of it should look? My graph should look? Let's move it. So my graph should look like what? There's my zeros. Do you have any other piece of information? My y-intercept, where is it? -1. That makes sense, right? I also know it's a positive graph, right? Because it's a positive coefficient here. And is that going to be a skinny graph or a fat graph? Based on the equation. Skinnier, right? It's going to be shooting up faster because 3 times x. So I know, I mean, that's not perfect, but approximately that would be the behavior of the graph. It should be skinnier than that, by the way. It should probably go down here a little bit more. Yes, sir?
So how would you find the rate of the curve?
Well, I would use, you mean the vertex? I would use negative b over 2a. Find my axis of symmetry, and then plug that in to the original equation, and I would get my vertex, just like we did last week. They're all related. All of them are related. What we're doing today is just learning how to do this right here. We're going further. Yeah, I can't teach it all in one day, right? So we've talked about graphing because every day that I talk about stuff like this, I want to relate it to graphing because that's what we're doing, right? So I'm showing you a little piece. Then next we'll do more of the quadratic formula. Then we'll do completing the square. Then we'll throw it all together. Okay? So we're just doing piece by piece by piece. Yes?
If we're avoiding calculators, what do we do for logarithms?
You can't avoid calculators for logarithms unless you want to use an old school table. Okay. All right, so let's do whiteboards and clickers. So if you don't have a clicker on your desk already, if you're a B and my B's are right here, make sure you have you already have a clicker. B's get the clicker, A's get the whiteboard. Okay, so I'm going to start the clickers. So person A is writing. Person B is telling person A what to write. No, Mo, you shouldn't be writing. You're telling him what to write, okay? Then, once you guys come up and agree, if the person that's supposed to be talking is stumped, then person A, you should be helping him out, like probing him, like, hey, remember, why don't you try this? All right, just don't make him sit there and stare at you, okay? All right, so go ahead and go. All right, let's see how you guys did. Those who put their answers in. All right, some of you are saying B, most of you are saying A.
Yeah, I put C.
All right, so how many of you really understand what square roots look like? So you know that a square root is really the side of a square? If the area of a square is 8, right? Then wouldn't the side be the square root of 8? Because the square root, length times width, right? Length times width would be the square root of 8 times the square root of 8 equals the square root of 64, which is 8. It's easier when it's nice numbers that have squares in them, like 9. Right? That's just 3 and 3. But when you have numbers that don't have squares in them, that's where we get square roots from. It's the inverse of a square. Most people haven't, but that's conceptually what it means. Does that make sense? Okay, so, but this is what it means. There's ways to explain it, but that's what it means conceptually. It's something tangible you can touch. It is an area formula. A square root is an area formula. Okay, so the square root of 28, I've got squares in there. We like squares because it makes us understand the number a little bit better, correct? So the squares in 28 would be 7 times 4, which is 7 times 2 squared. Well, just like I said over here, the inverse of a square is a square root. So the 2 actually can be simplified and come out of the square root sign. So whatever's a square gets kicked out of the square root sign. Because you don't need a square root underneath it anymore. Just like you wouldn't write this. Let's look at it this way, guys. The square root of 9. Would I write that the square root of 9 times, like this? Would I write it like that? No. I would write it 3 times 3 equals 9, right? Okay. Let's do another one. Try this one. Switch. One. Let's see. Okay, guys. Let's see here. What are the factors in 216? 2 and 108. Which is? Alright, why are you guys trying to make it more difficult than it is? Alright. Okay, guys, so 2 times 3 squared times 3. When I do this, I usually cross them off. Like, I've got my 2, I've got 3 squared, I've got my 3, and that's going to be 2 squared. Alright, everybody with me so far? Yes? Yeah, doesn't matter. So, if I break these numbers down, who gets kicked out? 3 gets kicked out, 2 gets kicked out. What's left over? 3 and 2, which is 6. What is the square root of 6? There isn't a square root of 6. So let's approximate. 4 and 9 is between 4 and 9, which is between 2 and 3. So what would you guess? 2 point what? 2.4, I'm going to say. So what this is really saying is I have 3 times 2 is 6 root 6, right? Which is really 6 times 2.4. Without a calculator, that's what you should be able to do. So if I don't know what 6 times 2.4 is in my head, but I know that 6 times 2 is 12 and 6 times 3 is 18. So you'd say what? 13.8 is your guess? You're thinking 13.7? I'm saying, I don't know, 14.5? I don't know, let's see. First of all, so I'm going to backtrack. This is our original right here. This is what we found just by simplifying the square root. Correct? Janelle, turn around, please. This is what I found, correct? This is just what I was doing in my head, using approximating to see if I could find the right answer. But the square root of 6 is 2.4 times 6 is 14.69. So 14.7 is our answer. I'm just saying you need to have some number sense to make sure that you can back up what you're putting in those calculators. Do you have to do that? No. Is it smart to do that? Absolutely. Your mind should be thinking about what the answer should look like, not just putting it in a calculator, if you want to be successful. Just saying. All right, questions on this so far?
No.
Are we good so far? So 6 root 6 would be my answer. If I were to simplify that all the way down, I would get 14.7. Let's do another one. Switch. Okay, 5, 4, 3, 2, 1. So you all got that one. That one was pretty easy. Like Ryan said, you could do it in your head. So do this one, switch. Okay, let's see how you guys did. Fantastic. You're amazing. All right, you guys, let's move on. So let's try this one. All right, so you guys, I know you're really excited. It's almost the end of the day. Listen up. So now that we have practiced, guys, I need your attention. I'll wait. Now that we've practiced, okay, let's work something out like this. Okay, so first of all, I'm going to go ahead and simplify this radical. So that should be 10 plus or minus 2 root 5. Most of you should be able to do that in your head. Okay, that's the first thing you do. Second of all, if you had something like this, could you cancel these 2's? No. Because you have an addition sign in here. You could factor out a 2, right? Because the only reason that you can cancel like that is because 2 divided by 2 equals 1. This isn't 2 divided by 2. This is 2x's divided by 2. Evan.
Can you, like, divide everything by 2?
Yes.
X plus 2.
Yes. You can divide everything by 2. Wouldn't that be the same thing? Did you guys hear what Evan said?
Yeah.
I could take a 2 from everybody, and then I would have x plus 2 over 1, which is the same thing, right? Same idea here. I can take a 2 from everybody, or I could factor out a 2. So I would get 2 times the quantity of 5 plus or minus root 5 all over 2. 2 divided by 2 is 1. So now I just have 5 plus root 5 and 5 minus root 5. I'm going to approximate. How much do you think root 5 is? 2 point something, right? 5 plus 2 point something and 5 minus 2 point something. Do you see kind of what I'm doing now? Using what I know about radicals instead of just putting it straight into a calculator. But when I put in a calculator, it's 2.2. Yes. So you get 7.2 and 2.8. Those are my two roots. Okay? All right. Here's another one. Try this one. All right, so let me show you how I did this one. 48 is 6 times 8 or 12 times 4, which would be 4 and 4 squared, good, times 3, which is 4 root 3. So 6 plus or minus 4 root 3 over 3. Root 3, how much is root 3? 1.5, somewhere around there. 1 point something. But 1.5 times what? Times 4. Let's find out how much exactly. The square root of 3 is 1.7. I'm not plugging and chugging. I'm thinking about it logically as I go. So 4 times 1.7 is, anybody got it already?
Yep.
6.8.
See?
Plugging and chugging, plugging and chugging. 6 plus 6.8 over 3 and 6 minus, you guys are being too loud. Okay. So let's finish this up. What do I get? 6 plus 6.8 should be something like what? 12.8 divided by 3?
Yeah.
Which should be something like what? 3 point something? See what I mean now? Rather than just sticking this in a calculator and going, well, I hope I'm right. Right? Like Evan did and proved it's right. And 6 minus 6.8 should be negative 0.8 divided by 3. All right, 12.8 divided by 4. No, divided by 3. It's 4.2, am I correct? Sounds pretty correct to me. It's not that bad. As long as you understand what you're doing, right? Yes. Yes. This will be on the quiz tomorrow. 2 of them will look like this. All right, guys. Good job. All right, there's way too much talking. I will keep you after if I have to. All right. What did you learn today?
Hey, don't plug and chug.
Don't plug and chug. We learned how to simplify radicals, right? When would you need to use the quadratic formula? When it doesn't factor. The person next to you is absent. How would you explain approximating a radical?
How would I explain approximating?
Find what you do know and find the middle of it, right?
Oh, yeah.
They're back there. Guys, I'm recording and there's way too much shuffling.
Okay.
On your assignment sheet, I want you to write for your closing thought. The square root of 111 is closer to blank because. So that's your final thought for today. Yes, please put the clickers back.